Hello, thank you for attending this presentation. My name is Gabriele Pulini, Product Marketing Manager of the Scalable Verification Solutions Division within Siemens EDA. What is Veloce proFPGA and how is it positioned in the hardware-assisted verification market are the main topics that I will cover on this presentation. Siemens EDA strategy is to create a holistic and scalable accelerated verification solution to address the needs of the different project teams that contribute to the design and verification of today's most complex system on chips. This within a consistent set of solutions and workloads for the various target applications. Verification acceleration solutions are essential to timely manage the development roadmap of today's complex devices spanning from artificial intelligence, 5G communication, Ethernet, autonomous driving assistant, high-performance computing applications. The key is to create a consistent methodology that addresses the new verification challenges on top of the functional verification and validation of the hardware architecture. New applications allow designers to perform a pre-silicon verification of the peak and average power consumption, analyze the performance of the device, integrate and verify the software, the testability infrastructure, and track the overall verification coverage metrics. All these with the old solutions virtualized or with physical connection to the real hardware environment that will mimic the real device operation on the final system. This strategy magnifies the productivity of the whole project team. We have seen the hybrid configuration solution Veloce Icon, the boost on capacity, debug, and multi-user flexibility brought by Veloce Strato Plus hardware emulator, the enterprise prototyping capacity and flexibility offered by Veloce Primo, and now, with Veloce proFPGA, we address the needs of the individual software engineers with a dedicated desktop prototyping solution. With the Veloce proFPGA addition, Siemens EDA is leading the path that targets a wide availability of the best qualified hardware and software engine for a specific verification task and for accelerating market adoption of our customers' products. In fact, the Veloce proFPGA desktop prototype solutions brings the performance to every software engineering desk and lab. And now software engineers can create their own customized hardware verification solution, connecting to PCI Express or USB interfaces, for example, and to their hardware and software debug instruments. Furthermore, this portable desktop prototyping solution becomes a collaborative platform among teams, including the end customers. Pre-configured systems can be delivered to the end customers, offering them the possibility of starting developing and verifying their application well before any silicon availability. It's a shift left of the old verification cycle, from conception to the hands of the final customers. One tool doesn't replace the others. It's the opposite. The triad we offer works one for all and all for one, with a very innovative methodology to accelerate the development process of the most complex devices and systems available today. The main advantage and differentiator of the Veloce proFPGA system is the architecture that offers best-in-class modularity, scalability, flexibility, and portability to serve the most demanding verification requirements coming from today's hardware and software engineers. Veloce proFPGA systems offer three types of motherboards, the Uno, Duo, and Quad, on which different types of FPGA modules can be plugged and mixed easily, as well as peripheral memory and protocol interfaces boards. As a use case example, the engineer can use the proFPGA Uno system for IP or sub-system-on-chip development and can reuse the same FPGA modules for the complete SoC and ASIC prototyping by simply plugging the same proFPGA module from the Uno on a Duo or Quad motherboards, regardless of the type of FPGA used on the new systems. This innovative and smart technology offers maximum reusability and highest return on investment because the new proFPGA modules based on the latest FPGA device, such as the View 19P or Stratix 10 GX 10M, are compatible to the previous proFPGA generations. That means all existing proFPGA motherboards, FPGA modules, daughter cards, and accessories can be all reused in combination with the new proFPGA modules and systems. If capacity needs increases with the evolution of the system-on-chip design, it's possible to easily connect together 5 Veloce proFPGA quad system to scale it to an even larger system with a capacity of 1.2 billion ASIC gates. This modular architecture based on FPGA modules with a fixed system infrastructure also makes more efficient the integration of the latest and largest FPGA devices coming to the market. In fact, today we have the proFPGA systems based on both the largest FPGA Xilinx View 19P and Intel GX 10M. The Veloce proFPGA scalability, modularity, and flexibility allows to expand the verification reach of the prototype solution, adding extension boards for memory modeling and hardware interfaces to the external system. Nearly all FPGA I/Os are available on a rich number of what we call the extension sites, which are used for the FPGA to FPGA high-speed interconnection, or for connecting extension board such as memory, protocol interfaces, and application-specific boards. This way, the user can model the Veloce proFPGA system to meet exactly his design verification requirements and can scale the system capacity up in a very easy way if it is required. This architectural approach offers a maximum flexibility and IP capacity for what we call in-circuit interconnection and for adapting off-the-shelf proFPGA daughter boards for PCI Express, Gen 4, Gen 5, DDR4 memories, USB 3, QSFP+, MIPI, HDMI, SATA, Gigabit Ethernet, debug interfaces, or user application-specific extension boards. And from the software side, we can say that the same software flow that accelerates the setup of the Veloce Strato Plus emulator, the Veloce Primo Enterprise prototype, is now brought to the engineers for accelerating the bring-up of their desktop prototype solution Veloce proFPGA. The Veloce OS software is a complete automated software that removes the tedious task to ensure the proper functionalities of the FPGA prototype solution. On top of the synthesis front-end process, the software guarantees that the clock tree is properly mapped on the FPGA reconfigurable logic. Gated clocks are well propagated. Timing hazards are avoided. The memories are automatically inferred and mapped on the available physical memories on the board. And the timing constraints are met for maximizing the performance without incurring timing violations in the circuit under test. I would like to conclude that Veloce proFPGA dramatically lowers the adoption barrier of the FPGA desktop prototype solution. Together with the performance it is possible to reach thanks to its architecture innovations, the solution is easy to deploy and engineers can now bring up on their lab their own environment quickly and reliably. Veloce proFPGA is based on the latest high-end FPGAs from Xilinx and Altera. Yes, both the devices family are supported today. It has been designed for high performance, and the choice of one FPGA per module architecture approach offers the required modularity for expanding the capacity as needed, as well as offering a sufficient input and output connections for connecting the interface boards required for creating the verification workload specific to the target application. Flexibility means also the possibility to use the desktop prototype within various types of workload, with onboard test benches in circuit connections to external hardware as Ethernet generators or PCI Express buses, or virtual modes for higher degree of flexibility use. And what about the bring up of the design under test on the prototype? Veloce proFPGA desktop prototype solution shares the same front end as the other solutions of the hardware-assisted platform and relying on the Veloce Strato Plus golden model that can be used for debugging the most tedious problems during the design bring-up and verification process. To finish, I would like to thank you for your time and for letting me tell you about the Veloce proFPGA. Thank you.